Okay, so in part 2 of Compound Inequality section, we're going to look at the word or this time. So in the previous lesson, in part 1, we looked at the word and. So we talked about what does it mean if we have a compound inequality with the word and. So that was in the previous lesson. So in this lesson, we're going to use the word or. All right, so remember a compound inequality. A compound inequality is where you have two more inequalities, and in your course, we're going to be dealing with two inequalities that are joined by the word and or. So in part 1, we talked about and. In part 2, we're going to talk about or. All right, so let's look at this first example. Okay, so we're going to solve this compound inequality. So let's suppose we had x is less than 2 or x is, let's say, greater than 5. All right, so x is less than 2 or x is less than 5. Now listen carefully to this. Remember in part 1, we talked about an and statement. Now we're talking about an or. An or, you're gonna discuss this differently, but some similarities. So you're looking for the solutions. When solving this, you're looking for all the real numbers that are less than 2 or all the real numbers that are greater than 5. So in an or statement, your solution to this compound inequality is any real number that satisfies this one or satisfies this one. Not both. It doesn't have to satisfy both. Okay? Just as long as it satisfies at least one of these. An and statement, it has to satisfy both. An or statement, it had your solution has to satisfy either one, this one or this one. Okay? All right, so keep that in mind. So your solution has to satisfy either this one or this one. An and statement has to satisfy both. An or statement, either one. Okay, so as we go through the discussion, we're going to come back and talk about the phrase, it has to satisfy either one. Okay, so the process is the same in terms of how you're going to find the solution set. You're gonna do the same thing we did previously. So remember, this is gonna be your work. This is the work here. All right, so let's do the work. So you're gonna graph each one individually. So let's graph x is less than 2. So here's x is less than 2. So let's say this is 0, this is 2. So I'm going to put an open circle and then shade to the left. So that's the solution to that first inequality. Now let's do the next one. So we're graphing x is greater than 5. And see, it helps if you align. You got to align this, otherwise you're probably going to mess up your final answer. So here's 0. Make sure you put 5 in the right place. So 5 goes here. So it's going to be on the right side of 2. So 5 goes here, open circle, and then shade to the right. Okay, now we're talking about an or statement. So the solution would be any real number that's less than 2. Okay, so listen to what it said. The solution to this compound inequality would be any real number less than 2 or any real number greater than 5. So what that means is that anything shaded is a solution. Anything shaded is a solution. Remember, any number less than 2 is a solution, or any number greater than 5. It has to satisfy both, either one, this one or this one. So all numbers that are solution here is a solution to both of these, or all real numbers here is a solution to this compound inequality. So anything shaded. So just remember, an or statement, any real number that satisfies either one, satisfies either inequality. So basically, you're also going to be using the word union. So anything shaded is a solution. So anything shaded is a solution. So now your answer, in terms of the graph now, so this is 0, this is 2, and this is 5. So your answer then will be 2, open circle 2 going to the left, and then open circle 5 going to the right. So that's your solution. So notice that in this compound inequality, this R statement, your solutions is made up of 2 separate parts of the number line. So you have this part of the number line and this part of the number line. Okay, so remember in our statement, anything that's shaded is a solution. So you're going to put all the shaded real numbers, all the solutions on this final graph. Notice though this time that with this R statement, you really get, in this particular case, 2 parts of the number line that's shaded. Previously, if you look at the others, there's only one part of the number line shaded. They were not going in separate directions. Okay, now your interval notation, this is how you're going to do your interval notation. All right, now let's talk about Mymathlab. In Mymathlab, when you write your answer, you're going to say, remember you read a graph from left to right. So you go from negative infinity to 2, negative infinity to 2, union, parentheses. Now remember Mymathlab now. This is Mymathlab. And then you're just going to put comma. You're going to tell you to separate your intervals using comma, and then parentheses 5, because 5 is not a solution, open circle, to infinity. All right, now, in your textbook, you're going to see this. And on your worksheet, I want you to use this as well. So remember your R statement, your graph, your solutions will be the union of these 2 individual graphs. So you're going to say negative infinity to 2 union, so the symbol for union is this U, and then 5 to infinity. Okay? All right, so on your worksheet or your test, use the word union. On Mymathlab, you have to use the word comma. Okay, so that was number 1. Let's look at number 2. All right, number 2, let's look at this. Suppose we had x is less than -1, or x is less than 2. X is less than -1, or x is less than 2. All right, so again, you're going to graph each one individually. That's going to be your work. Remember, this is an R statement this time. Always look for whether it's an AND statement or an R statement. AND means the intersection of the 2 graphs, and R means the union of those 2 graphs, anything shaded. All right, so you're gonna graph the first one. So here's 0, here's -1, open circle going to the left. Okay, here's the other one. X is less than 2. Here's 0, here's 2. We're gonna graph the solutions to this one. So we open circle to the left. Okay, now remember, this is a union. This is an R statement. So anything that's graphed that's a solution here, or anything that's a solution here, is a solution to the compound statement. So remember, anything shaded is a solution. So anything shaded is a solution. Anything shaded is a solution. All right, so kind of draw these little segments here on the first one. Draw the segments here on the second. Remember, you're not looking for where they intersect. That would be an AND statement. All right, this is an OR statement, so that's why I'm putting these little marks on anything that's shaded. All right, now let's think about your answer. So if you look at this, see how these 2 graphs, the arrow is pointing to the left. So you're going from negative infinity, now let's stop at -1 because you have some shaded parts here as well. So you're going from negative infinity all the way to 2. Negative infinity all the way to 2. So remember, anything shaded is anything shaded. So negative infinity, don't stop here. That will be an AND statement. That will be an intersection if you stopped here. You want the union of anything shaded. So go all the way to 2. All right, so your graph, this is 0, and this is 2. You put an open circle to the left. So that's your graph. The interval notation, you're going to say comma, parentheses, negative infinity, comma, 2, parentheses, because there's an open circle here. All right, number 3. Okay, number 3, suppose you had x is greater than 2 or x is greater than or equal to, let's say, 0. So x is greater than 2 or x is greater than or equal to 0. All right, so again, your work. Graph each one individually. So here's 0, here's 2. Since 2 is not a solution, we're going to put an open circle, and I want to shade in all the real numbers greater than 2. Over here, let's graph the next one. Here's 0. All right, so I want to graph all the real numbers that are greater than or equal to, so I'm going to put a closed circle, 0, going to the right. All right, now remember, this is an OR statement. So an OR statement means anything shaded. So it's the union of anything of these two graphs. So anything shaded. So these are shaded, these are shaded. So anything that's a solution to either one. So remember, an OR statement has to satisfy either one. This one. So this compound inequality, these are going to be solutions to this compound inequality, and these are going to be solutions to this compound inequality as well. Okay, but you're going to put these two together now. So your answer now, remember, this is your work. That's not your answer. Don't do that as your answer. So you answer the graph, remember, anything shaded. So anything shaded, you're going from, when you read a graph from left to right, so you're starting at 0, and you're going all the way to infinity. So don't say from 2 to infinity, because that will be an intersection. That will be an AND statement. So you're going from 0 all the way to infinity. So you graph, this is 0. Now 0, because the closed circle, because 0 is greater than or equal to 0. And then to the right. Now your interval notation, you're going to say bracket 0, because a closed circle, comma, infinity, parentheses. Now remember, infinity and negative infinity, always use parentheses. So that's number 3. All right, let's look at number 4. Number 4, suppose you had x is less than or equal to 5, or x is greater than or equal, let's make this x is less than or equal to negative 5, or x is greater than equal to 2. So x is less than or equal to negative 5, or x is greater than or equal to 2. All right, so remember, this is an OR statement, so any solution here is a solution to this compound inequality, or any solution here is a solution to this compound inequality. So your solution to this compound inequality will be the union of those two sets. So again, here's your work. So you're going to graph each one individually. So here's 0, here's negative 5. Since negative 5 is a solution because of the equal sign, you can put a closed circle, and you're graphing all the real numbers that are less than that. So that's your solution to this inequality here, which is also a solution to this compound inequality, because remember, this is an OR statement. So your solution to the compound inequality with an OR statement is any real number that satisfies this one, or any real number that satisfies this one. All right, now let's graph the next one. So here's 0, here's 2. Again, closed circle, because 2 is a solution because of the equal sign, and you go into the right this time. And so again, anything shaded is a solution to this compound inequality. So the OR statement, remember, is a union of these two graphs, anything shaded. So your answer, so here's 0. So your answer will be from negative infinity to negative 5. So that's negative 5, closed circle. So negative infinity to negative 5, union, and then from 2 to infinity. So remember, anything shaded. So negative infinity to negative 5, and then from 2 to infinity. Closed circle, going to the right. So that's your graph. That's a graph. All right, so your your interval notation. And remember, in this particular case, your solution is 2 parts of the number line. Here it was just one little part. Here it's 2 parts. So just like we did in this example, remember how we're going to write this, depending on whether you're using Mymathlab or you're doing this on a test or worksheet. Okay, so in Mymathlab, you're going to say, remember, we read the graph from left to right, so you can say negative infinity, the arrow's pointing towards negative infinity, so negative infinity to negative 5. Don't forget parentheses with infinity, negative 5 with a bracket because of closed circle, comma, and then from 2, bracket 2, comma, to infinity. And then your textbook, you're going to say negative infinity to negative 5, bracket union 2 to infinity, bracket 2 to infinity. All right, number 5. Okay, now let's suppose in number 5 we had this. Suppose we had x is greater than 3 or x is less than 6, less than or equal to 6. So x is greater than 3 or x is less than or equal to 6. Okay, so remember this is an OR statement this time. So any real number that satisfies this is a solution to this compound inequality, or any real number that satisfies this is also a solution to this inequality, to this compound inequality. So we graph each one individually. So this will be your work. So you're going to graph, if this is 0, this is 3. So you're graphing open circle, anything to the right. So x is greater than 3. The next one, x is less than or equal to 6. So this is 0. Make sure you put 6 in the right place. So 6 will be to the right of 3. This time 6 is a solution. So it's a closed circle, and I want to shade in all the real numbers less than that. All right. Now remember, this is an OR statement. So anything shaded is a solution. Anything shaded is a solution. So I want you to look at this. So as I go from left to right, notice I'm going from negative infinity. Now again, don't stop here. So anything shaded. So notice what's being shaded. So I'm going from negative infinity, and then notice it just keeps on going, right? Because of the arrow right here. See this arrow right here? Keeps on going. So anything shaded is a solution. So I'm going from negative infinity to positive infinity. Every part, every real number shaded. See this real number here? Is this number right here a solution? Yes, because it's a solution here. Is this number right here a solution to this compound inequality? Yes, because it's a solution to this one. So anything shaded is a solution. So in terms of your answer, your graph, if this is 0, basically what you're going to do, since any number is a solution, any real number is a solution, you're just going to graph, you're going to do this with the number line. Just kind of shade it like this, and then put arrows on both ends. There's your graph. So the whole number line is your solution set. Any real number is a solution. Now, your interval notation, remember you read a graph from left to right. So I'm going from negative infinity, all the way to infinity. And that's it. That's your graph. That's your solution set. So that's what it looks like. So notice that when doing an OR statement, sometimes you'll get your final answer being 2 parts of the number line, just like this. Sometimes you'll get your final answer being just 1 part of the number line, like this. And then sometimes it's going to be the whole number line. Any real number is a solution. And notice how it looked, how your work looked. Remember, this is your work, this is your answer. Okay, so that's going to take care of the OR compound inequality.